In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a difference. Evaluate the following limit using L'Hopital's rule. So if I plug in 1 straight away, I get the natural log of 1. So natural log of 1 is 0. So right now I have 1 divided by 0 here, which can't happen, which is an issue. And then if I plug in 1 here, I also get 8 divided by 0. So as we approach 1, remember we're not actually plugging in 1 necessarily, but as we approach 1, we're getting 1 divided by a small number and 8 divided by a small number. So we really have this infinity minus infinity situation, which is indeterminate. So I'm going to combine these fractions together to use L'Hopital's rule, because L'Hopital's rule requires a fraction. So we're going to say that the limit as x approaches 1, and I'm going to find common denominator here, so I'm going to say 1 times 8x minus 8 over, this would be 8x minus 8 times natural log x minus 8 natural log x over 8x minus 8 times natural log of x. So we multiplied basically by the opposite denominator on top and bottom. Let's do some distributing. We end up with 8x minus 8 natural log x all over, that'd be just 8x minus 8 natural log x. Now we can actually factor an 8 out of both of these terms. So let's do that to make it a little simpler. So limit as x approaches 1, factor an 8 out of the top, we get 8, parentheses, x minus 1 minus natural log x over 8 x minus 1 natural log x. So the 8's will cross out and we end up with x minus 1, should write the limit there, x minus 1 minus natural log x over x minus 1 natural log x. So we've done some algebra, now we're ready to apply L'Hopital's rule. So we're going to say that this is equal to the limit as x approaches 1 of the derivative on the numerator, so x minus 1 minus natural log x over the derivative of the denominator, which would be, bracket here, x minus 1 natural log x. When we do the derivative of the numerator, derivative of x is 1, derivative of negative 1 is 0, and derivative of natural log x is 1 over x. So we have 1 minus 1 over x divided by, I'm going to have to use a product rule here, so I'm going to say u is equal to x minus 1, u prime is 1, v is natural log x, and v prime is 1 over x. U prime times v, so I have natural log x minus, no not minus, plus 1 over x times x minus 1, so we have 1 over x times x minus 1. Now we want to see what happens here, and we can see that we're going to get something indeterminate. We plug 1 in, we get 0 here for the natural log of 1. We plug 1 in here, we also get 0 on this side. We plug in 1 right here, we get 0 on top. So we have 0 divided by 0, this is indeterminate still. So we're going to say that this is equal to the limit as x approaches 1 for the derivative of the top again. And when I say the derivative of the top, I'm going to do some algebra here. I'm going to move this x up. So I'm going to write this as 1 minus x to the negative 1. And then I'm going to do some algebra right here as well. So this is the derivative. So this is before doing the actual derivative. I get natural log x 1 over x times x will be just 1, so I get plus 1. And then 1 over x times negative 1, that's going to be minus 1 over x, which would be x to the negative 1. Now I'm going to actually take the derivative, so I'm going to say that that's the limit as x approaches 1. And derivative on top here, that's 0. The negative 1 comes to the front, so I get positive x to the negative 2 over derivative of natural log x is 1 over x. Derivative of 1 is 0, and derivative of negative x to the negative 1, that'll be positive x to the negative 2 power. So if I write all this together, we get 1 over x squared over 1 over x plus 1 over x squared. And remember, we have the limit as x approaches 1. If I now substitute 1 in there, I get 1 over 1 divided by 1 over 1 plus 1 over 1. So this is 1 plus 1 at the bottom, and I end up with 1 on top. So I get 1/2. So the limit as x approaches 1 for this function, f of x, is equal to 1/2. Using L'Hopital's rule.